Hello, algebra students. We're looking at the systems of inequalities again. We only looked at one example in class, so we'll look at some more. We want to sketch the solution of each system of inequalities. And since it's a system, we want to include all the points that make both of those inequalities true. Okay, there will be a region of the plane, many points that make each inequality true, and we will then look at the overlap of those regions. One part of the plane makes one of the inequalities true, another part makes the other inequality true, and where those overlap, those are the points where both inequalities are true. So let's look at number 2. So one of these equations is already in slope-intercept form, so that's going to make it easier. But one of them is not. So first thing we need to do is get this second equation into slope-intercept form. Okay, so let's do that. I'll work on that right over here. Oh wait, sorry, number 2, both of these are. Okay, we don't need to put these in slope-intercept form. They already are. So we just graph them. So the first one, the y-intercept is 1. So we put a point there. And the slope is 1/2. So rise over run is 1/2. Rise of 1, run of 2. Right? And gets us there. And then we connect those points with a line. I'll try to do a little bit better. That's it. And now we need to shade one side of that. Oh, this should have been a dashed line for this first one. Let's see if I can erase part of it and make that dashed. Is this gonna work? Oh, that's pretty good. Oh, it's erasing part of the graph too, though. Yeah. Okay, I'll try to do this a little bit better. So I need to be careful the way I erase it. Don't want to erase the graph. Erase there, there. It's not too bad. So there's our dashed line. And we want to shade under it. And what I'm going to try to do is shade this with a fine, and this is pretty fine already, but can we make it a little finer maybe? There, let's try that. And then maybe this will be similar to when you shade with a really fine pencil. It seems to work pretty well on these. This might be a little too fine. We'll see if we can make it work. So that's below that one. Okay, so we'll draw another line. We'll use a different color to draw the other one. And it's going to be a solid. Okay, we're working on this one now. Okay. So, actually I need to make this line fatter for it. Like that. Okay, so the y-intercept of this one is -2. And so we go on the y-axis to -2. The slope is +2. So rise over run is 2 over 1. Go up 2 over 1. Gets us to that point right there. Oh, we lost our other point. Up 2 over 1. Okay. And we're shading above this one because it's greater than or equal. So we'll make our line really fine again. Maybe not quite as fine as last time. And we're shading above the red line. I think I'll try the next one a little bit different. I think it works fairly well though to show the overlap, although it's not as dark as I hoped. Switch back to the blue. The blue is below that one. And then when you can recognize where the overlap is, you can sort of cheat and just color it in intentionally darker, just the overlap part. Make it show up. So I'm doing it with both of the colors. We'll try to make the next one look better. Okay, so that is the graph of that one. Not the most artistic, a little bit ugly, but it will work. Okay, let's look at the next one. Number 3. Okay, this is a pretty good problem. It's different. You see the first equation does not even have a y in it. So we've got to think about how we're going to graph that one. The second one is in slope-intercept form though, so that helps. So let's see here. Let's take a look. Let's graph that one first. X greater than or equal to -2. Okay, so the line is going to be the boundary. Remember, the line on these that we graph is always the boundary of the region. So we look at the line x equals -2. So that is right here. It's a vertical line. It's where x is -2. Okay, so whenever you have one that just gives an x, just has x in it, that's going to be a vertical line because that's the line where x is the same. Okay, x is -2 all along that line, right? Because here's -2 right there. And y is a lot of different things on that line, but x is always -2. So that's the line. And we want, this time we don't look at above and below, right? We just read this. X is greater than or equal to -2. So which side is that? Well, it's to the right, correct? That's where numbers are greater, to the right, on when you are on the looking at the x coordinate. When you're looking at the direction of the x axis, things are larger as you go to the right. So this says x is greater than -2, so x is to the right. I'm going to try shading. I'm going to try it not quite so skinny this time. Kind of shade a diagonal, and we need to go all the way to the edge. Not sure if the sharp pencil method is working. Some people use pencil and it works really well. On various on computers, you have all kinds of different options. Okay, so that's shaded that one. Now let's switch colors. Try that. And graph the other one. It's in slope intercept form. The intercept is +2. So that's 2 on the y-axis. So it's right there. We can graph that intercept. The slope is -1/2. So that means it could be -1/2, or it could be, we could graph it as 1/2, and those are mathematically the same thing, and they will give us the same line. So let's do the first one. Rise of -1 run of 2 gets us to right here, and we're going to graph that. And this time it says greater than or equal. So we do want the solid line like I drew. But then we want it shaded above. Everywhere above that line. Okay, I gotta be able to draw a better line than that. Maybe a little better. Okay, everywhere above that, because it's greater than or equal. So I think those work pretty good, those colors, right? Really shows it shading, and it helps if you are using a different direction with the pen or pencil or whatever you're using. I think that really helps it show up better. Okay, so that's that one. That's the region that solves both. Now we have one where the equations are not in slope-intercept form. So we do have that extra step we have to do on this one before we do anything else. We have to have them in slope-intercept form. At least that's the way we're used to graphing. You could graph another way, but this is overall the best, I think. So first one we'll put in slope-intercept form. Do it over here. That's 2x minus y is greater than 3. So we want to get y by itself. So we subtract 2x from both sides. On the left we have negative y, not y yet. That's greater than negative 2x plus 3. So all we've done is move the 2x to the other side, so to speak, subtract 2x from both sides. On the left it goes away. On the right we have negative 2x plus 3. We'll divide everything by negative 1 now. Okay, that has the effect of changing the signs. I guess we can go ahead and write it down. Oh, we better not do it like that though. We have to change the direction of that symbol. It's currently greater than. We have to change that to less than. So we'll do it like this. We'll divide by negative 1. We will flip that right now. Negative 2x divided by negative 1 and plus 3 divided by negative 1. So everything's divided by negative 1. And let's see what we get. Y. Oh, and we flipped the sign to less than, like we needed to. It was greater than. So you have y is less than negative 2x over 1. It turns out to be positive 2x minus 3. Okay, so that's that one. And we're going to have to put the other one in slope-intercept form as well. So we might as well go ahead and do that. It's currently like that. 3x plus y greater than 2. Subtract 3x from both sides. On the left, you have just y, and that's greater than negative 3x plus 2. So this is not too bad to graph these now. So the first one we did, this one, we'll graph it. It's less than, so we will have a dashed line here. So the slope, the intercept is negative 3. And the slope is 2. So rise over run, 2 over 1. Rise of 2, run of 1 gets us to right there. And that's our 2 points. We connect them with a dashed line this time. See how I can do on my dashed lines. They're even worse than my solid lines. Okay, so that's that one. And we shade below it. Something like this. These long strokes get kind of difficult to shade. Okay, so the other one, y is greater than negative 3x plus 2. Okay, so that's in slope-intercept form. We have the plus 2 here, and the slope is negative 3. So that's down and to the left. No, wait, down and to the right. 1, 2, 3, and over. And we're lucky because it's right on top of that one. I need to change colors here, though. Whoops. Let's see which one we want to use. See how that does. So, I already made the points blue, though. That's okay. I should change those, though. Well, I've got too much stuff I've drawn since then. They'll just stay blue. Okay, so we'll connect them. Seem to cross right on that same point. Now, again, the place where these cross doesn't matter for this problem because these are just boundaries. So the place where the lines cross, that's not so important. Okay, and this has to be erased as well, part of it, because that equation also is, I'm sorry, it's not that inequality is greater than instead of greater than or equal. So let's do it like that. Okay, and then see, switch colors. And this one we are shading above because it's this one here. Okay, look at the last one you did always because you might have had to flip the sign or something. So the last one is the one that's most complete and correct. It says greater than. So we shade above that line. Okay, so it's everywhere above the brown dashed line. And we sure can't see the other line anymore, can we? Well, not liking the way the shading's turning out. But I think we can see one region is shaded by both, and that's this part in here. Let's see, gotta switch colors to do the to shade below that line. So the problem is that dashed line doesn't show up very good. So this is not turning out like I hoped. So it's that region. I'll just make it all a little bit darker so we can see it better. That's the region. And hopefully the next one will work a lot better. Make some more dark brown to mix in. Okay. Well, that's one we have done one now where we had to convert to slope intercept form, and we've done one that had a vertical line in it. So we've done some of the more unusual type cases. Let's see if we have any more of those. The first one, slope intercept form already. 3 and 4 also had most of those are in, well, I'm sorry, number 3, one of them's in slope intercept form, one of them is just a vertical line, x greater than or equal to -2. So I think that's pretty good. Yeah, I don't think there's anything we need to look at in the rest of these examples. So, just a couple more. So that's it for now. Shading is a little bit difficult unless you have just the right kind of pencil. So I hope that it cleared up any questions that you had. And, you know, see how they go. Let me know if you have trouble. And we'll see you later.